Sir.
Okay, so last time we discussed monotone function, right? So what we discussed last time, uh, there is a bijective function f from R2 minus 1 to 1. This is what we know. Also, we saw that there is a bijective function g from interval to R. Is it correct? So there is a bijective function
Hello.
so there is a bijective function from interval to interval, correct? F from any interval to any other interval. Is it correct?
Yes, sir.
So moreover, there is a bijective function from any interval AB minus 1 to 1. Right? So this is what we discussed. Now we also saw that what is monotonic or what is increasing function. Decreasing function, right? Then we also saw that if f is increasing, then f is 1 1, right? If f is decreasing, then also f is 1 1 function. This is what we saw. If you remember this, these points we discussed last time. So either increasing, if function is increasing, or decreasing, function is 1 1. So I will give you an exercise. So let a and b are any two real numbers. A function f defined on real numbers defined by fx is equal to ax plus b is strictly increasing. Strictly increasing if a greater than 0 and is strictly decreasing if a is less than 0. Because if you look at function ax plus b, basically what is it? What is its y is equal to ax plus b? What is the graph of this function?
Straight line.
Straight line. And what is a in this case?
Slope.
Slope. And therefore, if slope is positive, function is increasing, right? Line is increasing, and slope is negative, line is decreasing. So this is a easy exercise. You should work it out. Correct? So if a function f from a to r is both increasing and decreasing, then what can you say about such function? Which function is both increasing and decreasing? Then, from your previous knowledge, which function is both increasing and decreasing?
Sine
function.
Constant function, right? So a function f is both increasing and decreasing, then f is a constant function. Right, so you know what is a constant function. For example, if you look at f of x is equal to 1, this is a constant, means for every real number or for every point in domain, value is 1. And if you look at the graph of this function, it is a horizontal line. It is both monotonically increasing as well as decreasing. That you can prove by easy calculations, easy arguments. So you just try to prove that these two exercises. Anyway, now we want to learn something more than that. Suppose, okay, suppose you have two functions, right? So suppose you have set A here, set B here, and set C, right? So f is a function from A to B and g is function from set B to C, right? Then can you, what is a function from A to C, direct from A to C, right? So we want to understand such functions now. Suppose f is a function from A to B and g is a function from B to C, then the composition of f and g is denoted by G composite F. Here order is important. G composite F means what? Suppose you take any point here, x. If you apply function f on x, you will get element in where? So if you take point x from A and apply f, where you will get the image?
B.
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 That image is suppose y, which is image of x. Now can I apply G on this y? Can I apply G on?
Yes.
Yes. Can I apply G on X?
No, sir.
No,
No.
right? Because A A is some different set, may not be in the domain of G. We can apply G on every element which is in the domain of G, and we are sure here that B is a domain of G, so we can apply G on every element of B. So Y is inside B, so we can apply G. So therefore its image. So if we apply F on X, it will give us element Y, and if we apply G on Y, so what we'll get? We'll get some element here Z, which is G of Y. Correct. So, but what is G of Y? So Z is image of Y under G. But what is G? What is Y? Y is F of X, because Y is image of X under F. And therefore, when we write composite function, first action is of F and then action of G. Right. So G composite F of X. So in this way, we write the composition. So what is the order? Which function acts first? Is it clear? Which function acts? So first action of F and then action of G. And this is a function from which set to which set? What is the domain of this composite action? And therefore, if you look at X, and what is a direct image now? Z. Direct image of X is Z. And therefore, what is the domain of this composition? What is the domain for this composition?
Set A.
A, right? Because we apply this composition on A and we'll get directly image inside
C.
C, right? Is denoted by G circle F or G composite F from A to C, and is defined as what is the action of G composite F on element of A, right? So we want to apply this composition. That means if we apply composite function on element of A, then what is the action of this composition on X? So what is action? Is action of G on action of F on X. Right. This is what the action of composite functions. Composite function is something new function, but how it acts on any element of A. So first action of F on X, and then whatever element you get, right? So G of Y. So whatever element you get, apply G on that. So this is what we define the composite function. For example, if we define F from R to R by Fx is equal to x square plus 1, right? And define G from R to R by Gx is equal to sine of x. So what is the situation here? This is R, this is real line R, and F is defined in this way. This is, and now G is defined from this R to R. Right? So what is the composite function? This is composite function G composite F. That means first action of F. So under this function, can you tell me what is G composite F of 3? What is G composite F of 3? What is the action of, what is the image of 3 under this composite function?
Sin 10.
Sin 10, right? Because
Sin.
correct, it is G of F of 3. But what is F of 3? What is F of 3 by definition? F of x is x square plus 1. So F
10.
of 3, right? So F of
10.
3 is 3 square plus 1. So which is G of 10. And then what is g of x? So g of 10 is sine 10. Right, so this is what the action of composite function on element. So in general, so in general, for real number x, right, you choose now any element in the domain of f. You choose any element in the domain of f. Then what is G composite f of x? What is G composite f of x? So what is it? G of fx.
Sine of
So
x,
Sine of x.
sine
right,
of x square plus 1.
right. So G of f of x is x square plus 1. X square plus 1 is some number which is in domain of G, whatever it may be. But apply G on this number, it is sine of this number which is x square plus 1. Correct? So this is a composition. Correct? That means how do we define composition? So order is important. G composite f means first action of f, right? First action of f, which is x square plus 1, and then on that action of g. Correct? So fine. Okay, so now we want to study properties of this composite function. Right? So we want to study properties of composite function. Suppose f is from x to y and g is a function from y to z. Now, what questions can be raised from this case? What questions can be raised in case of composite function? This is set x, this is set y, this is set z. This is f, this is g, and now we are interested in g composite f direct from x to z. Now, what can be the questions which we can study? Right? You understand? You should be able to raise the questions. What questions we should study, or we can probably study about the composition function. Do you understand? Do you understand the question? Yes. So what questions can be raised means what? Something is in front of you, right? Suppose somebody gives you some gadget. Then what do you think? Okay, so what are its features, right? What are its properties, how it how much it costs. So these are the questions immediately come in your mind. So if you look at now this situation, you have function from x to y and this function from y to z, then what is the curiosity? This is a research attitude. Okay? What things you should know about this, what questions you can raise.
Can we find the composite function from G to F, means F composite G?
So you can think about key. If you are given function from x to y and you are given function, so suppose you are given function from x to y and g is a function from w to u, then can you define a composition?
No, sir.
No, sir.
Answer is no, but can you impose some conditions so that you can define composition?
If Y is a
Yes, sir.
subset of W
If Y is subset of W,
for F of G.
is it correct?
For G of F, it should be inverse.
No, no.
If a W should be a subset of Y.
That means images of this goes inside W. If Y means codomain of F is inside domain of G, then certainly we can think about composition. Yes. Do you understand? But anyway, forget about it. We can define composition if the codomain of F is inside domain of G, right? What is happening in this case? If codomain of F is same as domain of G, in that case our situation is simple. But if it happens that this is codomain of F and domain of G is something bigger, right? And then it is functionally defined on this. So this is what Y and this is what X and this bigger set is W. Then we can think about composition, correct? Because if you take some point here X and its image will go inside Y and G is defined on whole W. So G is defined at this point also. Certainly we can apply G. Right? Certainly we can apply the G on this element. But right now don't worry about this. So this is not essential at this point. Only thing is we can think about composite function if domain of codomain of first function is inside domain of second function. That's the point that we are actually assuming the simple situation here. But other than that, what you can think, what questions you can raise. So if f and g are 1 1, then is fg composite f11? This could be a question, right? Am I right? If both of the functions f and g are 1 1, then can g composite? Can composition be 1 1 function? Is it a valid question?
Yes.
Right, so can you raise some valid questions? If f and g are 1 1, then g composite f is 1 1. Right? What could be the another valid question you can raise?
Can composite function be the bijective function?
So if f and g are onto, right, 1 1, if both are 1 1, then composition is 1 1. If f and g are onto, then what can you say about composition? It is true actually. And if the 1 and 2 are true, if above two statements are true, then what can you make the general statement? Suppose f and g are both 1 1 and onto. F and G are 1 1, then composition is 1 1. F and G are onto, then composition is onto. Suppose F and G are both 1 1 and onto. Can I say that G composition F is 1 1 and onto? Can I say that?
Yes,
If,
sir.
yes, right? So if F and G, that means F and G are bijections. then is G composite F bijection?
Yes.
Yes, sir, it's bijection.
So from previous two points it is clear, but it is essential to prove point 1 and 2. Then we can believe third is also true. So let us prove first point. If F and G are 1, 1. Suppose F from X to Y and G from Y to Z are 1, 1 functions. Right? Suppose functions are 1, 1. What is our claim? What is our claim? G composite F, which is a function from X to Z, is also a 1, 1 function. This is our claim. That is what we want to prove. What we want to prove. X, Y, Z, F, and G. Now composition is from this X to Y, X to Z. What is this claim? What we want to prove? G composite F is 1, 1 means what? How do we prove 1, 1?
For every element, there is unique element in Z.
For
Every element in X, there is unique element, unique image in Z.
no, this is a definition of function. What is a 1, 1 function? Distinct
If
element.
x1 is,
Yes.
if x1 is equals to x2, then z1 equals to z2.
No, this is opposite of it. So that is
For all
distinct.
x,
X
y
does not
belonging to
equal to
A.
y, f of x does not equal to f of y.
So if x1 is not equal to x2, that then the images G composite F of x1 is not equal to G composite F of. That means if you choose two distinct points in domain of G composite F, then the corresponding images are also distinct in codomain of G composite F. This is what we want. Or what is this equivalent to? What is our claim? What is contrapositive to this? G composite F of x1 is equal to G composite F of x2. If images are same, then the pre-images are also same. This is another way to say that 1, 1, right? This is our claim. Remember this. Okay, so how to start the proof? How to start the proof? Let x1, x2 belongs to domain X. Suppose images are same. So what we expect? What do we expect?
The images are also same.
Three images are also equal. So we expect that x1 is equal to x2 for 1, 1ness. But we have not proved it. We expect this will be the answer. Okay, so how to get this? So what we are assuming? So G composite f of, but by definition it is G of f of x1 is equal to g of f of x2. So let y1 is equal to f of x1 and y2 is equal to f of x2. Where are these 2 points, y1 and y2? Where are these 2 points?
At B.
In set y, correct? Second set. Fine. Therefore, g of y1 is equal to g of y2. But what is the assumption? What is the assumption? G is 1, 1. Correct? G is 1, 1. And g of y1 is equal to g of y2. What does this imply?
y1 equals to y2.
y1 equals to y2.
Y1 is equal to y2. Why? Since g is 1, 1. But y1 is equal to y2 means what? What is y1? F of x1. And what is y2? What is y2?
f of x2.
F of X.
F of x2.
F of x2. But f is 1, 1. That is our assumption. F and g are 1, 1. So what does it imply?
X1 equals
x2.
x1 equals
X2.
x2.
Right? Why? Because f is 1, 1. F is 1, 1. And therefore, what is the final conclusion? Thus, G composite F, if we apply on x1, and if we apply G composite F on x2, and if it gives to be same image, then what we found? We found that x1 is equal to x2. G composite F is 1, 1. No matter which point you select, every time this is going to happen. If images are same, then pre-images are same. So we conclude that the composition function is also 1, 1. Is it clear? Is it clear?
Yes, sir.
Now, second point. Suppose f from x to y and g from y to z are both onto or surjective, 1, 1 or injective. So what is our claim? So what is our claim? G composite f, which is a function from x to z, x to z is onto. Correct? This is our claim. So okay, how to prove this? That is what we want. That is, we claim that. What is our claim? What we claim? G F. G composite F. This is G composite F. We want to prove that G composite F is onto. Means what? Means what we claim. Yes.
For every element in Z, there exists at least one element in X.
Right. Because G composite F is from X to Z and we want to prove that onto means what? For every element in codomain of this G composite F, can you produce X here such that that is what we claim. For each Z in Z, there is X in X such that G composite F of X is equal to Z. So you choose any element from Z, it has a pre-image. It has a pre-image. What is our assumption here? Assumption or hypothesis or given is what? F is onto, G is onto. F from X to Y is onto, G from Y to Z is onto. This is given data. And claim is composition is onto means for every element in Z can we produce pre-image of under G composite F. This is our claim. Okay, so what is the strategy now? How to start? How to start the process? See, this is our claim, right? Key for every element. So how to start? How to initiate the process? To initiate the process, because our process is for every element in Z, can you produce some image, pre-image in X? This is a process. How to start the process? So choose some element from Z and try to produce pre-image in X. Correct? So process starts with what? Let Z belongs to Z. Just close your eyes and select arbitrary element from Z. What we want, X in X, such that G composite F of X is equal to Z. So this we want actually. So start with Z, try to get X. Is it clear? So idea is clear. Yes. So you are you getting what I am saying?
Yes, sir.
Okay, so
Yes, sir.
now I have selected some element from Z and I want to produce X. Okay, what is a natural way without any difficult thing? What is a natural way to backtrack element X? So we want to backtrack the element in X. So what is a natural way from this figure? So I have selected Z. What naturally I can do? What I can do naturally, I will just go back in such a way that I can find something in Y. This is a natural way, right? Because from Z to X it is a long jump. But what I will do to make our life easy, I will just look at what is the easy for me. Just I will go to the Y which is very nearer, and then from Y I will look for pre-image in here. This is a natural way, right? Do you understand? Do you understand what I want to say?
Yes.
Okay, so what? How to write down this? So Z is in Z, and Z is a codomain of G. So since G is on 2, is G on 2? Is function
Sir.
G?
Yes.
Yes. And therefore, can I produce pre-image of Z under G in Y? Is it possible?
Yes.
Yes.
Yes. Since G is on 2, there exists Y in domain of G such that G of Y is Z. Fine. This is what I was saying. Just look at some simple jumps, and so that we can get take a big jump. So now I am backtracking pre-image of Z, but I can see that there is a pre-image in Y under G. So since Y is in Y and F is on 2, can I produce a pre-image for Y in X under F?
Yes, sir. Y is
Right?
equals to f of x.
Yes, sir.
So now I will produce pre-image of y. So y is in y and f is on 2. So there exists pre-image x in x such that f of x is equal to y. Right? So did we get a hold of pre-image of z now? Right. So this is a way. Suppose you want to send a message from z to x and x is a far away. What we'll do? We'll send a message from z to y which is connected by g, and then y is connected with x, so y will send message to x. Right, so this is a way we are backtracking the pre-image of z. So we'll therefore x belongs to x such that what is g composite f of this. So we have caught x now. We caught x. How did we caught this x? Because and look at this particular x. Is it the required x? Therefore, there exists x in x such that. Is it the correct x? Correct x means what? If you apply g composite f on this x, can it give us z? So g of fx, right? G composite f of x is g of fx. So fine. Then what is fx? What is image of x now?
Y.
Y. So it is g of y. But what is the image of y under g?
Z.
Z. Right? So it gives us back z. Therefore, gx is the correct. Right? So it is a conclusion. For each z in z, there exists x in x. For each z in z, we can produce x in x such that g composite f of x is z. This is the way we backtrack the image, and we are just using the given data and definition of onto. Correct? Hence, g composite f is onto. Fine. Third point. So, if suppose that f from x to y and g from y to z are bijective functions. So these are bijective functions. Then what will happen? G composite f is 1 1. Am I right? Can I say that G composite f is 1 1?
Yes, sir.
Yes.
Right, because when I say f and g are bijective, that means f and g are 1 1, and therefore by part 1 of this theorem, the composition is 1 1. Now when I say f and g are bijective, that means f and g are onto, and if f and g are onto, their composition is onto, so G composite f is onto, correct? And therefore, what can I say? G composite f is
Bijective.
Bijective.
bijective. So if two functions are bijective, their composition is also bijective. Right. Okay, let if I define function from R to R, f of x is equal to 3x plus 5 and I define another function g from R to R, g of x is equal to x plus 1, right? Now what is a composite function? What is a composite function? G of fx. G of fx. G of
3x.
x plus 1, right?
3x.
So f of x is 3x plus 5. And what is g of 3x plus 5? G of 3x plus 5 is
3x plus 6.
3x plus 6.
3
1,
plus 3.
right? This is now y, and g of y is y plus 1. So this is 3x plus 6. 5. Now what is preimage of 10 under G composite F? Now I want to produce G image under G composite F. So what I will do? So here domain of F, here codomain of F, right? And here G and codomain of G, and 10 is here. So how to produce preimage under composite function? I will produce preimage here, and then I will produce preimage here. That will be the correct preimage. So what is here y and what is here x? Right. So first I will try to find. So first step is find y such that g of y is equal to 10. Right. So what is y such that g of y is equal to 10? What is g of y? That means y plus 1 is equal to 10, and therefore what is y? 9.
9.
Right. So we got 9 here. And what is the next step? Next jump. Find x in R domain of f such that g of x is equal to y, which is 9. Fx. Right. So find x here such that f of x is equal to this y or 9. That means what is f of x? 3x plus 5 is equal to 9. And therefore what is x? What is x?
4 by 3.
4
4
by
by
3.
3. And therefore we have backtracked, we have traced the preimage of 10 under composite function. And what is this? What is the preimage now? 4 by 3. So what is the procedure? We just backtrack preimage in domain of G and again backtrack under F. Now check that G composite F of 4 by 3 is 10. Is it true?
Yes.
Right? You can, here functions are easy. So we know direct formula for G composite F, and therefore 3x plus 6 if you solve for 10 for x, then also you'll get it. Right. So G composite F alternatively G composite F of x is what? 3x plus 6, and we want it is to be 10, right? Therefore what is it? 3x is equal to 4, and therefore x is equal to 4 by 3. So in this way also we'll get directly, and if you track it from y to x, then also it is same. Anyway, so in this way we can think about composite function. Further, can we define f composite g in this case, in these two particular functions? Can we define f composite g?
Yes.
because here domains, codomains are same. So what is it? F of gx. F of gx. So when I say f composite g means what? First I am looking at function g and then I am looking at function f. Right. So then the direct function is what? First g and then f. Right. So what is in this case f of gx? But gx is what? X plus 1. And therefore what is f of x plus 1? F of
3x plus
3, f of x is 3x plus 5. So f of x plus 1 is 3 times x plus 1
8.
plus 5. Therefore it is 3x plus 8.
8.
3x plus 8. So now question is G composite f of x same as f composite g of x? Is it true?
No.
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 Right? Therefore, the order matters. Which order you are taking may not be same, right? G composite f is not same as f composite g. They are different functions. It depends on what are your functions f and g. Right? Now further, what properties you can think about the composition functions? What properties of composite function you can think about? Suppose x to y are functions. So if G composite f is 1 1 1 1 or injective, then now we are looking in the opposite way. In the previous case, what we were looking for, if you go back to the previous theorem, what previous statement says, right? If f and g are 1 1, right? If f and g are 1 1, then G composite f is 1 1. What is opposite way? What is opposite way?
If g of f is 1 1, then g and f are 1 1.
So that can be a question. If composite function is 1 1, then what about the functions f and g? So if composite function is 1 1, then are f and g 1 1? Then f is 1 1. What about g? What about g? G may not be. Sometimes it may be, sometimes may not be. Doesn't matter. But definitely f is 1 1. If composite function is 1 1, then certainly f must be 1 1. G may be, may not be. That is a different thing. Right. So opposite, that means converse is not true. Now, what could be the another question? If G composite f is onto, then what could be the question? Then what? G is onto. What about f? F may not be.
May not be onto.
Right? When I say G is onto, then F may not be, because it may happen that sometimes G composite F is onto, but F is not onto, but certainly G must be onto, no choice. So given F is function from X to Y, G is function from Y to Z. Right? Suppose G composite F is 1 1. Suppose G composite F is 1 1. What is our claim? What is our claim? F is 1 1. F is 1 1. Correct? That is, what do you want to prove? F is 1 1 means what? What do we want to prove? That is, for x1 and x2 in domain of x, fx1 is equal to fx2 implies x1 is equal to x2. This is what we want actually. Correct? Is it clear? What is our claim?
Yes, sir.
So how to start the process? Let x1, x2 in the domain of f such that fx1 is equal to fx2. Now we want to check whether x1 is equal to x2. Right? Suppose x1 and x2 says that fx1 is equal to fx2. Now apply. So where are fx1? Note that. Where are these fx1 and fx2?
In Y.
Into y.
Y.
Can I apply g on these two numbers, two elements?
Yes.
Right? So
Yes.
I can apply g because these two numbers are in domain of g. Fx1 and fx2. And if I apply g, can I say that the action is same? Can I say that action of g on these two numbers is same?
Yes, sir.
Yes, because same, they are same numbers. Fx1 is equal to fx2, same numbers. Therefore, if I, for example, if I define f of x is equal to 3x plus 1, and I say that 2 is equal, x is equal to 2, then I can say that f of x is equal to f of 2. The same thing, right? If x is equal to 2, then f of x is equal to f of 2. That means fx1 is equal to fx2. That means g of fx1 is equal to g of f, because elements are same. Then if I apply g, then action is also same. Correct? But this is same as what is the next step now? What does this imply? What does this imply? What is assumption? G
X1 equal
so G composite F is 1 1. This is assumption. And what is the situation of G composite F of x1 is equal to G composite F of x2? Images are same, and this G composite F is 1 1. By definition of 1 1, can I say that x1 is equal to x2?
Yes.
Right. So what is the conclusion? Thus, we started with fx1 is equal to fx2, and we reached at x1 is equal to x2. So if fx1 is equal to fx2, then x1 is equal to x2, and hence we conclude that f is 1 1. Okay, so proof is clear.
Yes, sir.
Right. So we'll stop here because time is over. you try to write down the next second proof for on2.